Have you ever wondered how your phone battery powers up or how plants make food? This secret lies on redox reaction, the nature's of way of transferring energy and electrons. Today, we'll uncover how these fascinating processes drive everything from chemical reaction to life itself.
First up, oxidation. What happens here? Oxidation is a chemical process where a substance loses electrons. Oil, or known as oxidation, is lost. The oxidation state of a substance increases. It becomes more positively charged, and this can occur in several ways, such as a substance joins with oxygen or when it loses a hydrogen. And now, let's talk about reduction. Reduction is the opposite of oxidation, where it's a chemical process when a substance gains electrons. Rig, also known as reduction, is gained. This causes the substance's oxidation state to decrease, meaning it becomes more negatively charged. Reduction often involves the removal of oxygen or the additional of hydrogen to a substance. But now, here's the twist. Oxidation and reduction always work together in a redox reaction. The relationship between oxidation and reduction occurs simultaneously in a redox reaction, where one loses electrons and another substance must gain those electrons. The reaction charge conservation is assured by the interrelated relationship.
So, what is redox reaction? Redox is a term that stands for reduction and oxidation. So, how do we determine which substance is oxidized and which substance is reduced? First, we can look for the transfer of electrons in the reaction. The one losing electrons is oxidation, and the other gaining the electrons is reduction. So, here are quick examples of reduction and oxidation in a reaction. As you can see here, magnesium is losing electrons, meaning it is oxidizing, while right here, iron is gaining electrons, meaning it is reduced.
What is an oxidation number or oxidation state? Oxidation number or state is a number assigned to an atom in a molecule or an ion to indicate the degree of oxidation and reduction of that atom. It also represents a hypothetical charge atoms would have it bonds to another atom. So, what does it indicate? Electron loss and gain. A positive oxidation state indicates that an atom has lost electrons. It means it has been oxidized, while negative oxidation indicates that an atom has gained electrons. So, it means it has been reduced. A real-life example of redox reaction is a process of rusting. Oxidation of iron. When iron reacts with oxygen in the presence of water or moisture, it undergoes a redox reaction where iron is oxidized, losing electrons, and oxygen is reduced, gaining electrons. In this reaction, iron is oxidized to iron 3 ions, while oxygen is reduced to hydroxide ion. This result is the formulation of rust, which is primarily iron 3 hydroxide. So this is a common example of redox process occurring in everyday life, rusting.
Let's try to identify oxidizing agent and reducing agent. So oxidizing agent makes oxidation happen. To make oxidation happen, something has to take electrons. Take note that oxidation is the loss of electrons. Reducing agent, on the other hand, makes reduction happen. To make reduction happen, something has to give electrons or donate electrons. And reduction is the gain of electrons. Please take note that the thing that is being oxidized is the reducing agent, and the thing that is being reduced is the oxidizing agent. So we have here an equation example to identify which is the oxidizing agent and reducing agent. So please take note that oxidation takes place when the oxidation number is going up, and reduction takes place when the oxidation number is going down. As we can see in the picture, the calcium has 0 oxidation number, and over here, the calcium has +2. So it means that oxidation takes place because calcium loses electrons. So we have here next the chlorine. It has 0 oxidation number, and next it has -1. So it means that the chlorine is being reduced and it gains electrons. And as we have said earlier, that the thing is being oxidized is the reducing agent, and the thing that is being reduced is the oxidizing agent. So it means that the calcium is the reducing agent and the chlorine is the oxidizing agent.
Here's an example of zinc and copper reaction. For this example, you are going to find out the reaction's reducing and oxidizing agent and to figure out what kind of process the reaction is experiencing. We have here the reactants zinc plus copper with an oxidation number of 2 yields into zinc +2 plus copper. Can you figure out where the reducing and oxidizing agents are and what process the reaction is experiencing? Correct. The one that loses electrons and gets oxidized is the reducing agent, which is the zinc, and the one that gains electrons and gets reduced is the oxidizing agent, which is copper.
To help identify less obvious redox reactions, oxidation numbers provides us a way to track electrons before and after a reaction. But how can we determine the oxidation numbers of atoms in a reaction? Well, there are certain guidelines we can follow to determine the oxidation states. Free elements in its natural uncombined state always has an oxidation number of 0. For group 1A in the periodic table, alkali metals, the oxidation number is always equals to +1. For alkaline earth metals, it's always +2. For transition metals, it can have multiple oxidation states depending on the compound. For monoatomic ions, atoms with a charge, the oxidation number is always equal to the charge. For example, in NaCl, Cl has a -1 charge, so the oxidation number is equals to -1. For halogens, it is typically -1 unless it is combined with oxygen or other halogens. In compounds, hydrogen is +1 when bonded with nonmetals and -1 with metals. For oxygen, it's typically -2, but there are certain exceptions. In peroxide, it's -1, in superoxides, it's -1/2, and in compounds with fluorine, it's +2, while for fluorine, it's always -1. Lastly, the sum of the oxidation numbers in a neutral compound must be always equal to 0, but for a polyatomic ion, it must be equal to the ion's charge. For example, in H2O, a neutral compound, the sum must be equal to 0. For a polyatomic ion such as SO4 with a 2 negative charge, the sum must be equal to -2. By knowing these guidelines, you can now easily identify the oxidation states of atoms or compounds.
Wow, amazing! To conclude, redox reactions are fundamental to the natural world and numerous man-made technologies. They are essential for energy production, corrosion processes, and biological function. Redox reactions aren't just chemistry, they are life in action. From fueling your body to powering batteries, these tiny electrons exchanges drive the world. Master them, and you will unlock the secret to energy, innovation, and transformation.